अच्छा, we started reactions. We started combustion reactions, and I told you, okay, you can have all sorts of combustion reactions, and we did all of them. You can just figure out the formula using the general formula, and we can write an equation for combustion. For example, heptane is an alkane with 7 carbon atoms. So I'll just quickly do this. 7 carbon atoms means the general formula of an alkane is CnH2n plus 2. So it's going to be 7. 7 into 2 is 14. 14 plus 2 is 16. So it's going to be C7H16 plus oxygen के साथ it's going to react with oxygen, and it would produce carbon dioxide and a water molecule. That is your entire reaction, and there would be 7 carbon dioxide and there would be 8 water molecules, and you can count the oxygens. So that's 7 into 2 is 14 plus 8, that's 22. So I need 11 O2s, okay? So you can balance. Every time it's going to be pretty much the same reaction. That's combustion. Now we're going to quickly start doing reactions for alkanes. Now the reactions of alkanes are that if you have an alkane, the first reaction that happens is known as a substitution, or you can call it chlorination. It's also known as, I mean, if it's with bromine, it's bromination, or halogenation in general. So it's also known as, generally, it's just known as halogenation. Okay, these are all the terms that are used to describe this reaction. The reaction is a photochemical reaction, which means that it involves sunlight. Sunlight has to be present. So it's a photochemical reaction, and the reaction is what is the reaction? The reaction is that if you have any alkane, let's say I have an ethane molecule. Alkanes are saturated hydrocarbons with all bonds saturated, meaning that all bonds are single bonds. ठीक है, so ये आपके सामने alkane है, and it would react with, let's say, chlorine. There's only one condition for the reaction, and that is the presence of sunlight. You can call it sunlight or the presence of ultraviolet light. That is the only thing that is needed for the reaction. And what's going to happen in the reaction is that one of the hydrogens, तो ये आपके पास alkane था, it had all these hydrogens. So one of them, in any one of them, it's a random process. It could be any one of the hydrogens. So I'm going to pick this one. Is going to get substituted. ठीक है, get rid of that. And substituted by what? Substituted by chlorine. I mean, if you're reacting it with the chlorine, it's going to get substituted by chlorine. That's the whole reaction. So any one of the hydrogens is going to get substituted. What would the hydrogen do that has been substituted? It would bind with the other Cl and form a molecule of HCl. So that's your entire reaction. And the reaction doesn't really end there. The reaction could continue. Like this molecule still has plenty of hydrogens that can get substituted. So it could be like a chain reaction. I mean, the reaction, I mean, there's one Cl already substituted. You would react it with chlorine again, and there's ultraviolet light present again. Again, what would happen is that any one of the hydrogens, so any one of the hydrogens, the rest were all hydrogens. Now, any one of the hydrogens is going to get substituted by chlorine once more. So it gets knocked out, and in its place, you're going to have Cl taking over, and an HCl molecule would be produced simultaneously with it. Okay, that's the whole reaction, and the substitution just keeps on happening. It just keeps on happening. It's only going to end when all of the hydrogens are going to get substituted. जब सारे के सारे hydrogen जो है ना, they would get substituted by Cls. That's when the reaction would probably end. ठीक है, तो it's like a chain reaction. Reaction continues. until all hydrogens are substituted by Cl. So the reaction just keeps on happening. In simple words, if I have any, so simple words, let's say heptane plus chlorine, I want to write an equation, and there is ultraviolet light present. Okay, so it's heptane plus chlorine, and there's, अच्छा इसमें क्या होगा? So I'm just going to draw C7. I'm not going to draw. It's going to be C7 and H16, and I'm reacting with it with chlorine. Now one of the hydrogen is going to get substituted, so it's going to become C7H15, and instead you're going to have Cl, one Cl, and the H that gets knocked out is going to produce HCl. ठीक है? ये clear है सारों को? Iram, is this clear? Is this clear? Sidra?
Yes, sir.
Yes.
अच्छा चलो ठीक है. So it's basically any one of the hydrogen is simply going to get substituted by Cl. That's it, and that's your complete reaction. And it could be more than more than a single hydrogen. You could have two hydrogens getting substituted, or you could have all of the hydrogens might get substituted. So even that is not like at least one H would be substituted. So this is the reaction, and this is chlorination or halogenation, and this could also happen with bromine. So it could either happen with chlorine, or you could do the same thing with bromine as well. अच्छा बनता क्या है? बनता इसमें products क्या बनते हैं? The product says, what are the name of the products? This is ethane. It was originally ethane, but now it's chloroethane. क्योंकि अब ethane के अंदर ना एक chlorine आ गया. So there's one chlorine present. This one was what was this? This is also chloroethane, but it's dichloroethane. Dichloro meaning okay, the ethane has two chlorines now. So the naming is very simple. Okay? Or you can so chloroethanes, or if it's with bromine, like if I do this reaction with methane, let me write another reaction. So I have methane and I'm reacting it with bromine. Remember, halogens are diatomic, so unko Br2Cl2 etc. लिखोगे. अच्छा, one of the hydrogens is going to get substituted by CH3, and one of the hydrogen would get substituted by Br. और वो जो H हटा है ना उसको जाके HBr बना देगा. This would be known as bromomethane. मतलब methane था लेकिन now it's bromomethane because there's one bromine also attached in the molecule. साथ clear है ये reaction?
Yes, sir.
अच्छा खैर और तो कुछ भी नहीं है इसमें. That's it, this reaction. Also remember कि this reaction, specifically this reaction, just hold on, give me 1 second. अच्छा, the other thing I wanted to add about this reaction was कि the substitution is possible in any carbon chain. It's not just limited to alkanes. So substitution is possible with any alkane chain or any carbon chain. Okay? Lots of molecules have these carbon chains. So that is possible anywhere. But almost all organic compounds are basically uh, a bunch of carbon and hydrogen atoms, and they might have a functional group. For example, if you look at this carboxylic acid, तो ये जो बाकी part है, the rest of the chain, it looks exactly like alkane. But इसमें, if you look at this part, this looks exactly like, if you ignore the carboxylic acid group. So, I mean, this molecule could also undergo substitution. ठीक है? For example, if you have ultraviolet light or sunlight, so what could happen is that one of the hydrogens, for example, this one, वो जो carbon chain में, it might get substituted. And it might get substituted to form उसकी जगह Cl आ जाएगा. and over here there's going to be Cl in its place. और वो जो H हटा है उससे जाके that would form HCl. ठीक है, is this part clear? Ahmed, clear है?
Yes.
ठीक है, तो मैं बस ये कह रहा हूँ कि this reaction is not just limited to alkanes. This substitution reaction could happen with any carbon chain. Now moving on to the next part, which is moving on to the next part, which is क्या है next part हमारा? The next part is कि so the next part is कि you have there's a reaction called cracking. Now, cracking is a reaction in which it's a very useful industrial reaction, which uh, एक मसला होता है कि large molecules, wherever you have large hydrocarbon molecules or any organic molecule. As a long time back, we did fractional distillation, and I told you about large hydrocarbon organic molecules. There's one thing that's wrong with large hydrocarbon molecules. The bigger the molecule is, they have higher melting and boiling points. So they have higher melting points, which means they would be kind of like solids, like waxes. So they have higher melting points. They also have, they're more viscous. They don't flow easily, and they are less flammable as well. तो अब अगर आपने ज़मीन से ना oil निकाला है, तो the main purpose of actually extracting all that oil was you wanted to burn it to produce energy. But large hydrocarbons are not very flammable. Waxes, they don't burn easily. बहुत ही slow burn करती है. If you burn a candle wax, it burns very very slowly. So large hydrocarbon organic molecules, they're very less flammable. So they're not useful. These are definitely not. They are not useful. So what you should do is you should simply break them down into smaller pieces. So these molecules over here are broken down. So these molecules are simply broken down into smaller pieces. So they're broken down into smaller pieces, and uh, the so it's a simple process of breaking down into smaller pieces, and smaller pieces or smaller molecules, they're more useful. They're a lot more useful. Why? Because they have low melting and boiling points. So इसका मतलब है they would be gases or gaseous. Uh, why is being gaseous a good thing? The good thing is they can flow easily through pipes if they are gases. Solid, uh, which is why your petrol, ठीक है, the reason it's a good fuel is because it could you could easily transport it, and it could flow through tiny pipes through your engine, etc., and you can easily burn them. Why is methane gas, which is having low melting and boiling points, why is it useful? Because it can easily flow through pipes. Now candle wax would not be able to do that, or your car polish would not be able to do that, although they are flammable as well, but they can't really flow. So gaseous or volatile liquids, they are very good at flowing. So low melting and boiling points is a good thing. They're less viscous. They don't tend to stick to things. मतलब candle wax जो होगी वो तो stick कर जाएगी. It would stick to everything. Uh, but if you look at petrol, which is your car fuel, it's not going to stick to things. or methane gas that's coming in your heaters, etc. That's not going to stick to things as well. Plus, they're more flammable as well. They burn very easily. तो खैर ये smaller pieces useful है. So literally this is done. You have a big molecule with, let's say, 100 carbon atoms, and you literally break it down into pieces, into smaller pieces. Uh, so that is what cracking is. And what happens during cracking is that these smaller pieces, let's think of a big molecule. Uh, let's think of a 40 carbon atom alkane. According to the formula, this would be 82, like 2n plus 2, right? So this is a big molecule. Cracking, as the word literally means, is this molecule is going to be cracked into smaller pieces. अच्छा, smaller pieces होंगे कौन से? They would be smaller alkanes. Alkanes का general formula क्या होता है? CnH2n plus 2. अच्छा, what else? There would be smaller alkenes. The general formula of alkenes is CnH2n. And or they could be the production of hydrogen gas. This hydrogen gas, H2 gas, could also be produced. Now, this doesn't mean that all three would be produced. I mean, there's a possibility that all three could be produced, but it's usually a mixture of the three. Uh, so it's not necessary that all three have to be produced. Smaller alkanes, smaller alkenes, and hydrogen gas molecules are going to be produced when you crack this molecule. And there's no formula for cracking. Like it's a, let's think of it as this big molecule, and you crack it into small pieces. Let's say there's a piece with 10 carbon atoms. There's a piece with how many carbon atoms? Let's say 25 carbon atoms, and you get a piece of molecule with 5 carbon atoms, right? I mean, the original molecule had 40 carbon atoms. I broke it down into three pieces. One piece had 10 carbon atoms, the other one had 25 carbon atoms, the third one had 5 carbon atoms. Now, it could be alkanes, there could be alkenes, or there could be hydrogen gas molecules. So let's assume that all of them are alkanes. So I'm going to assume that all of them are alkanes. So according to the general formula of alkane, the number of hydrogens over here is going to be 2n plus 2, that's 22. This would be 2n plus 2. If I do 2n plus 2, it's going to be 50. 50 plus 2 is 52. And if I make this an alkane, it's going to be 10, 2n plus 2. So that would be 12. So over here, I'm going to write 12. So I've broken it down into three alkanes. Now there's going to be a problem, and that problem is okay, why I can't. I said, remember, whatever you break this down into, it's up to you. It's your choice. But you could have broken it down into two pieces. I mean, what you could have done is like it's up to you. It's a random process, so you could have broken it down into two pieces, both pieces having 20 carbon atoms each, and let's say both of them are alkanes as well. So this would be 42, and this would be 42 as well. Or what you could have done is that you could have cracked it. I mean, it's not your choice. Cracking is a completely random process. Or you could have broken it down into a 10 carbon atom molecule and a 30 carbon atom molecule. So this one is an alkane, so that's 12, and this one is an alkane, so that would be 62. I said, now coming back to the main point, why can't all of them be alkanes? The reason is that if this molecule breaks down, this molecule over here, if you break it down, then the number of atoms that you get in all these molecules, they should sum up to be equal to this. I mean, these things are produced when this molecule breaks up. So if you add them up, they should be equal to this. Now, one thing you would notice is that the carbon atoms are adding up. यहाँ पे 10 carbon atoms and they're 12, 25 over here, और यहाँ पे there are 5 carbon atoms. So 5 plus 25 is 30, 30 plus 10 is 40. So they add up to 40 carbon atoms. But you will notice that the hydrogens are not adding up. Try and add all the hydrogens. 22, I mean, let's say 20 plus 50 is 70. 70 plus 10 is 80. This is 82. This is 84. And this will make it 86. Now the hydrogens I'm getting, if I sum this up, the carbons are, I'm getting the right amount of carbons, but I'm not getting the right amount of hydrogens. ठीक है, it's coming out to be 86. तो इसका मतलब है कि the number of hydrogens should be lesser because I mean you can't get more hydrogens if the original molecule had lesser hydrogens. So you can't get more hydrogens. तो आप क्या करो कि सारे alkanes नहीं हो सकते. Make some of them alkenes. So let's say I make this an alkene. Alkene का general formula is CnH2n. So it would be 25 and this would be 50. And I'm going to convert this into an alkene as well. Now it's my choice. I'm going to convert any molecule I wish into an alkene. I said now if I do this and I add them up now, the carbons are still 40. Count the hydrogens. 22 plus 50, that's 72 plus 10, that's 82. Now I'm getting the exact right amount of hydrogens. Is this point clear? Sidra, is this clear? Is it clear? Anna, is this clear?
Yes.
ठीक है. अच्छा, so it's your choice कि but whatever is produced, it has to be an alkane or an alkene or a hydrogen gas or a combination of all three. But the only condition is that they should all sum up to be equal to this molecule. अच्छा, इधर भी ये कर लेते हैं कि uh, now again I have an issue कि 20 carbons, so that's a total of 40 carbons. Like if you add up the hydrogens, it's 42 and 42, that's 84 hydrogens. So I mean, this molecule cannot produce 84 hydrogens. So what I'm going to do is I'm going to change the formula. I'm going to make them into alkenes. So let's change both of them into alkenes. What would happen? Uh, Alkene is CnH2n. So this is an alkene now. This is also an alkene now. So C20H40, C20 H40. Now I'm short of hydrogens. कि अब हाइड्रोजन्स को टोटल करो ना तो यहाँ पे 40 हाइड्रोजन्स है and there are 40 hydrogens over here. So that's a total of 80 hydrogens. So I'm short of 2 hydrogens. तो वहां पे ना फिर if you're short of hydrogens, bring in H2 gas molecule. वो भी तो बन सकता है. ठीक है, that's also a choice. So now if you sum up all of them, they should give you 82 hydrogens. Uh, this one as well, it's you're getting the number of hydrogens is more than the one this make this into an alkene. Yeah, पहली बात ये formula ही गलत लिखा हुआ था. So according to the formula of an alkene, this is C10 and H20. Add them up. This is an alkene, this is an alkane, and they sum up to be this, sum up to be equal to this. So remember this, it's up to your choice. You can break a 40 carbon atom molecule in whatever number of molecules you want. There could be uh, lots of molecules produced, but the rule is they should all add up to be equal to this thing. And they have to be either alkanes or alkenes or hydrogen gas. ठीक है. और ये याद रखना cracking का कि when you crack molecules, large hydrocarbons are not useful and they're broken down into smaller pieces which are more useful. ठीक है, which is why cracking is a very important process. अगर वो उसका याद है वो fractional distillation of crude oil के अंदर एक होता था कि वो बनता था fractional distillation of crude oil के अंदर ना bitumen बनता था. Now bitumen is this tar that you get. It's good for making roads, uh, but if you're getting a lot of tar, you have to break it down into smaller pieces and make it into more useful, convert it into more useful fuels. ये cracking and we missed one thing, and that is what are the conditions of cracking? Now the conditions for cracking are you use high temperatures, and the temperatures are usually greater than 450 degrees centigrade, and you use a catalyst as well. The catalyst that's used is known as pumice. It's a type of rock, also known as zeolite, Al2O3 plus, or a mixture of Al2O3 and SiO2. Uh, it's a type of rock. Pumice अगर मैं ठीक है, this is basically the rock pumice. Uh, well, it's a very common type of rock that's found in a lot of places. ठीक है? अच्छा, here's a board. अच्छा, here's a board. तो उसके अंदर pumice में होता क्या है? It's a mixture of sand and aluminium oxide. That's it. अच्छा, that's all about cracking. Cracking clear है सारों को? Is this clear? Sidra, is this clear? Ahmed, Saad.
Yes.
Yes, sir.
अच्छा, next part. अभी हमने कितना किया है? We did. अभी इसके questions जरा करो ना. As I remember, most of you should have. We did two things. ठीक है? Try and practice. ये जल्दी से करो. ठीक है? You still have time. Crack this molecule, and it's up to you. Let's say there's C30 and H62. Now it's your choice. जो मर्जी बनाना है, as long as it's going to be cracked into. I mean, crack it into three different pieces. ठीक है? It's your choice. Make an equation out of it. ठीक है? ये XYZ मैंने hypothetically लिखा हुआ है. Just break it down into smaller pieces. ये मैं board का भी link भेज रहा हूँ ताकि you can open the board at your end as well. अच्छा, ये करो C30 H62. Crack it into make two different equations of cracking. फिर write a substitution reaction. जो हमने chlorination वगैरह नहीं किया था. अच्छा, write a substitution reaction for a reaction of butane with bromine, or another one, propane with chlorine. ठीक है? ये तीन, the four reactions. Try and do this as soon as possible. Send me the. I'm waiting for the answers. ठीक है? 10 minutes में हो जाना चाहिए.